Today, I would like to tell you about what are zeros of a polynomial. Now, you have already studied what polynomials are, and you have studied that polynomials are like, for example, I'll just write this polynomial 2x plus 5, 3x plus 2. These are all polynomials. Now, when I say zeros, okay, let me bring a simple polynomial. For example, I would say x plus 2. This is a polynomial. Okay, now what should I do? Just forget the topic for now, just forget this topic for now. What should I do to make this x plus 2 the whole value? I want the whole value to be 0. That is, I want the total value to become 0. What should I do for that? Now, to make the whole value 0, now I know that this value will not change. The only thing that can change is, let me use a different color. I know that this value will not change. The only thing that can change is x, because 2 is a constant. It cannot change. Now, of course, the meaning of the word constant itself is that it doesn't change. Now, x is a variable. Variable means the value varies, the value changes. So I can change that. So if I put x1, if I put x is equal to 1, it doesn't become 0, it becomes 1 plus 2, 3. If I put x2, it becomes 2 plus 2, 4. So what should I do to make the value, total value 0? So, I will just write it as x plus 2 is equal to 0 is x is equal to, if I put this 2, if I bring this 2 there, it becomes x is equal to minus 2. So I know that if I substitute here minus 2, I can see minus 2 plus 2 is equal to 0. So it is just basically like that. What value of x makes the whole polynomial 0? That value is called 0 of the polynomial. If there are 2 or 3 zeros, then we can say they are zeros of the polynomial. Okay. So the 0 can actually become a 0 or some other number. I don't know if you understood that. That means suppose my equation is, instead of all this, suppose my polynomial is, let me come back to the same color, x plus 2 minus 2 is equal to 0. For example, this is my polynomial. Okay, and if I am asking you, please tell me the zeros of this, then it will be like the whole thing should be equal to 0. Now I know that 2 and minus 2 becomes 2 and minus 2 is already 0. So the only way of x becoming 0 is x should be equal to 0. So in this case, the 0 of the polynomial is 0 itself. But that is not always, Suppose the equation was x plus 5, or suppose the polynomial was x plus 5, and let me write the 5 a little more nicely. So if the polynomial is x plus 5, and if I'm asking you to find the 0, that means the whole thing should be 0. Then I just have to move this there, so that is x is equal to minus 5. So if I put x is equal to minus 5, that means minus 5 plus 5 is equal to 0. So you get it. This is how you solve a question when then they ask you find the zeros of the polynomial. Now I know you'll be asking, sir, why do you do all this? What is the use of all this? See, you will study that, because it's very difficult for me to tell you the use now. I'll just give you a brief overview, but I don't think you'll be able to understand it fully. But remember that zeros are actually pretty important, very important in engineering and in mathematics. I would say in engineering, zeros of a polynomial is very important. Very important. It actually shows us how to. It shows us many things. Now, when we say or when we want to find, see when we have an equation, for example, for example, if my equation is 2x plus 5, This 2x plus 5, I can actually show it in a graph. I don't know whether you have studied about graphs, but graph is basically a place where you can show a shape. So this 2x plus 5 is like this. So it crosses a point called 0, and where it crosses that point, what value of x this shape or this graph crosses the point 0, that is called the zero of the polynomial. That is actually the meaning of all this, but I don't think you'll be able to understand it now. So if possible, some other time I'll take it when you're already familiar about what graph is. So now I would just tell you, so to find this, for example, let me give you another question. 2x plus 8 is equal to, okay, 2x plus 8, this is a polynomial. Can you tell me what is the zero of this? So let us do to find the zero, that means the whole polynomial should be equal to 0. So what is the condition that the whole polynomial should be equal to 0? Let me 2x, if I put the 8 here, it becomes 2x equal to minus 8. Then if I divide by 2, it will x is equal to minus 8 by 2 minus 4. So if I substitute x is equal to minus 4, then I see that the whole polynomial is 0. Therefore minus 4 is the zero of the polynomial. I hope you are able to understand this thing. Now that is all about what zeros are. That's exactly. But see, there are more things. You're only studying a basic way of finding what a zero is. There are little more complex ways, difficult ways of finding zeros, but that you will not study in this class. Probably in the next year or the year after that. Probably in the next year. Now I would just want to clear up one thing. Usually usually when you have, let me use a pen. Usually when I say 2x plus 5 is equal to 0, and if I ask you to find x, the value of x, you will be like, okay sir, put the 5 here, so this becomes 2x. So why do you say put the 5 there? Is a number 5 jumping to the other side? Do you know exactly what happens when we say putting the 5 there? I mean, in really, what is happening when you say, is the number 5 jumping there? Or when I say 2x is equal to 5, so you say x is equal to 5 by 2, what is happening? 2 is walking under the number 5. Now what is exactly happening? Some of you might actually know it, but for those who do not know exactly what is happening, let me just tell you this. When I say 2x minus 5 is equal to 0, this applies for everything. I'm just using 2x minus 5 as an example. And okay, 2x plus 5. When I say 2x plus 5 is equal to 0 and I ask you to find the value of x, so what I'm doing is I have a plus 5 here. Now I'm going to add minus 5 to both these sides of the equation. This is the LHS, you know that this is the left hand side and this is the right hand side, RHS of the equation. Now I am going to add the number minus 5 to both this. See, before that let me show you one thing also. If I have x, if I say x is equal to see, if I have a number and if I say 2 is equal to 2, if I add 5 to both the values, what happens? It becomes 7 is equal to 7. So adding a value to both the sides of the equation will not change the whole value, you get it, or will not break the equation. But if I only add it to one side, for example, if I add some value to one side, then it becomes 7 is equal to 2. Is it true? No, it is false. 7 is not equal to 2. So you get it. If you just add some value at one side of the equation, the whole thing changes. It doesn't become an equation anymore. But if I add a same value to both the sides of the equation, it doesn't. It's the same applies for multiplication, the subtraction, division. If I multiply both sides by one value, nothing happens. It remains the same. The equation still remains. You get it. The value might change, but the equation still holds. 2 is equal to, like 7 is equal to 7. Now if I multiply the whole thing by 2, if I multiply both sides by 2, then this becomes 4 is equal to 4. See, the equation still holds. It is still equal to, it doesn't change. The condition is still true. But the value will change, that is fine. But we do not want this equation. We don't want a false value to come up. Now, why I told this is to make you understand this thing. Now I'm going to subtract I'm going to subtract 5 from both sides. So it becomes 2x plus 5 minus 5 is equal to 0 minus 5. I have subtracted 5 from both sides. Now what happens? This 5 plus 5 minus 5 is 0. So 5 plus 5 minus 5 gets cut because it is 0. Now therefore what happens? The answer becomes 2x is equal to minus 5. 0 minus 5 is minus 5. See, if you now check, this is why you get it like this. See, when you say 5 goes to other side, this is how this is actually what you're doing. This is exactly what you're doing. It is not that 5 is jumping to the other side, but when you directly write 2x is equal to minus 5, you are actually doing all this. You are all this, operations, subtracting minus 5 from both sides and simplifying it. You're just skipping those terms and just writing that the 5 goes to the other side. It is just, it is felt, or you're telling the other person that it's understood, You don't have to write all that always. So that is why it happens. It's not that 5 is jumping to the other side. Now again, let me just continue. Anyways, I brought this topic. So now what happens? So now let me divide both sides by 2. Okay, what happens? This becomes 2x divided by 2 is equal to minus 5 divided by 2. Now if I go a little more, it becomes 2x. 2 by 2 is 1, so it is x is equal to minus 5 by 2. Now do you understand what happened here? See, usually when we have this kind of thingy, we say okay, 2 we cross multiply and we say 2 goes below minus 5. But how does it happen? We divide the whole thing by 2, then simplify it, and then it happens that x is equal to minus 5 by 2. It is not that 2 jumps below 5. It is that this step, we are just skipping those steps because we consider that those steps are understood by everyone. Okay, so these are, I just wanted to tell this in addition to whatever you have already seen, like in the chapter polynomials. So I think this will be it for today. Thank you.